In this lesson, we will learn how to solve quadratics using the square root property. Again, we use the square root property only when the b value is 0, so notice here there is no something x, which would of course be whatever that something is, would be our b value. In this case, our a value would be 1 and our c value would be negative 16. So we only use it when b is 0. When we do solve using the square root property, typically, like when factoring or using the quadratic formula, we'll move everything to one side equal to 0. So for this one and for completing the square, we're actually going to move the c value to the opposite side. So notice I'm going to add 16 to each side, which gives me x squared equals 16. Then to solve, I will just take the square root of each side. So I'll take the square root of x squared, which is x, and the square root of 16, which is both positive 4 and negative 4. So my two solutions would be a negative 4 and a positive 4. Let's do a few more practice. Again, this one they're already separated for me, but if possible I would then divide each side by 9. Because 16 isn't divisible by 9, I won't do that here. Actually, I will do that here because I prefer to have that x squared by itself before I do any of my square rooting. So when I take the square root, notice the square root of 16 is 4 and the square root of 9 is 3, and I won't forget my plus or minus sign. So my solutions are positive 4/3 and negative 4/3. For my second, I will subtract that 75 to the opposite side. So 3x squared equals negative 75. I would divide by a positive 3 to get x squared equals negative 25. By taking the square root, I would find x is positive or negative 5i, I because it was a negative in the square root. For this question, this is already sort of put together for me, and so a lot of people would say, oh, well, I should FOIL it out and all of that, but I don't have to. It's all square root, it's all perfect squares already, so I'm just going to take the square root of each side. For my first, taking the square root of something that's squared just gives me x minus 4, and of course the square root of 25 is plus or minus 5. I need to get x by itself, so I'm going to add 4 to each side. So my solution is 4 plus or minus 5. Now, because 4 and 5 are both, real numbers and easy to work with, I'm going to go ahead and find 4 plus 5, which is 9, and 4 minus 5, which is negative 1. So those were my two solutions. For my second, when I take the square root, I get x plus 3 equals the square root of 20, which I would break down into the square root of 4 times the square root of 5, or 2 radical 5. Don't forget your plus or minus. And now when I subtract the 3, I find negative 3 plus or minus 2 radical 5. Now 2 radical 5 is not a real number. It's an irrational number, and that's not fun. I mean, it's a real number, but it's not easy to work with. And so I'm going to leave it in this form. If I had to separate my answers with a comma, as Alex will have you do, it would be plus 2 radical 5 and minus 2 radical 5. So I would not go any further with that radical 5. You do not turn them into decimals. Here are two for you to try on your own, so press pause, try both questions, then press play to check your work. For the first, again, I will take the square root of each side, which gives me x plus 1 equals, over here, again, I want to break this down into perfect square factors, so I would call this 16 times 2, which is 4 radical 2. I would subtract the 1 to the opposite side. Oops, forgot my plus or minus up there. And to separate my answers with a comma, I would write that as negative 1 plus 4 radical 2 and negative 1 minus 4 radical 2. For my second, I would move that c value to the opposite side, which gives me 4x squared equals negative 100. I would divide each side by 4, which gives me x squared equals negative 25, and then take the square root of each side to give me x equals plus or minus 5i. Separating those with a comma, of course, would be negative 5i and positive 5i for my two solutions.